Thank you for joining today's session of this tech webcast. This is the first session of our program. We're going to be talking about Site Recording Manager today. It's going to be a technical deep dive session. So this session will be covered by my colleague and very good friend, Ariel Sanchez. Ariel, can you introduce yourself, please?
Sure. My name is Ariel Sanchez. I'm from Costa Rica, but I live in Orlando. I work as a staff technical account manager for VMware. I've been with VMware 4 years. And I'm very interested in Site Recovery Manager to help some of my customers. And I'm also very interested in learning how to design it better. So that's why I'm also going to be working with Agustin here. Today we're going to have a technical session to just get familiarized with Site Recovery Manager. But next, I think in 2 weeks, we're doing a design session going over typical scenarios. And that's really what I think is going to be the most fun, like designing solutions with SRM.
That's right. Yeah, as Ariel just said, we'll have 2 sessions on this topic. The first one is a technical deep dive session, and the second one will be a scenario-based design session that will cover, a few or most of the common use cases for Site Recovery Manager 8.4. So once again, thank you for joining, and I hope you to enjoy this session. If there's any questions or you wanna, say something, you want to share something with us, feel any message or question on the chat, covering that window during the session.
Yeah, we also have some polls in there. So if you want to answer some of the polls that we have put in the webinar, we're always looking to improve. And we also want to introduce Phoebe Kim, who is our other co-leader. And Phoebe, maybe you want to give an introduction to who you are.
Yeah, sure, of course. Hi, everyone. My name is Phoebe Kim. I'm a customer success architect at VMware. I am in Dallas, Texas. So today was a little cold for Texas, but it'll get hot very, very soon. But happy to be here, and I'm very lucky to have our, Ariel and Agustin let me join, especially to learn Spanish. That was one of the goals that I have for helping with the webcast. So I'm very excited to be here.
Yeah, and I don't think, Agustin, you have introduced yourself and talked about how we're going to be doing sessions in several languages.
Yeah, so hi, my name is Agustin Malanco. I'm part of Phoebe's team. Actually, we work together. The 3 of us work for VMware. I'm a customer success architect as well. I'm a triple VCDX. So we're trying to share a little bit of knowledge that we have right now, experience, and also basically let all the audience understand how we design solutions based on the BCDX framework. So that's going to be part of a second session. So it's a pleasure to be here with you guys and all the attendees. So thank you.
Perfect. All right. So in that case, I'll share my screen and I'll get started. Today we have a pretty big session. It's almost 80 slides or so. And the reason for that is that we want to give you a good idea of how Site Recovery Manager works. And I'm not even digging into the replication mechanisms. We'll touch on them a little bit, but they are also very, every vendor that does storage arrays that have replication that is supported has its own literature, and VC Replication has its own literature. So we are going to try to focus on Site Recovery Manager, and I'm going to try to be as brief as possible, but trust me, this is going to be probably over an hour. But the idea here is that you have a good theoretical base so that when we get to the design session, you can always refer back to this session as your study notes. Perfect. So you can see the agenda here. We already did the introductions. We're going to talk a little bit more about tech webcasts, but we're going to do a technical overview, then talk about some of the architectural features and restrictions of SRM that may influence our design. And we're also going to talk about how it fits with other products and what you should be aware of when designing solutions. I already gave you a little bit about me. If you're here, you heard about the VMware Tech Webcast. Again, this is a community effort that we are doing as VMware employees. We're sanctioned to do this webcast because we want to share this information and especially share it across many languages. You can find us on Twitter, TechVMW, or you can find us on GitHub at this link. And we have a YouTube channel where this talk will be uploaded. The presentation will be in the GitHub. Sources for this presentation were honestly the official documentation. This is all material that is available to anyone, especially that last one, the Site Recovery Manager Technical Overview. That is very much what I based this presentation on because it guides you through the concepts and what to think about. But all of this is required reading if you're going to be designing solutions for Site Recovery Manager. Documentation, the official documentation is also several documents in itself. You got an installation and configuration, an administration, a security guide, and then there's also plugins that are used with Realize Orchestrator. There's management packs for Realize operations, etc. So don't think that documentation is just one document, it's several documents. All right, so Site Recovery Manager is a business continuity and disaster recovery solution. It helps you plan, test, and run the recovery of virtual machines between two vCenters. So you always need at least two vCenters. It is an extension to VMware vCenter. So it basically relies on what vCenter offers. It basically uses what vCenter has available to it. We can do disaster recovery, we can do site migrations, and we can do a lot of testing without actually disrupting the business. So we'll talk a little bit more about that. So site recovery by itself, it doesn't actually replicate data. It relies on other replication mechanisms. And we're going to go deeper into them, but in basically they fall into 3 or 4 categories. That migration, however, what Site Recovery Manager does is the coordination, the management, the automation of a recovery plan. This is how we can tell it what's more important. We can tell it what we want to go where and how. So, one of the biggest features of Site Recovery Manager is that you can manage and test several things. You can test just an application, for example, or you can test a whole site. So features and benefits of SRM, and I'm going to try to read between the lines here. It runs at the vSphere level. It is application agnostic. You don't need to have particular solutions per application. You have site failovers, and you also have failback. So you can actually, once you actually move VMs from a protected site to a recovery site, you can turn around that protection and have it reprotect to the site. And we're going to go deeper into some of these things. I already mentioned that we have testing, that you can do a lot of plans and you can test those plans. It doesn't care about which storage you're going to use, as long as it's replicated. It's compatible with whatever vSphere is compatible with. And there's some gotchas there. We'll mention them. And it's also very aware that people may not have exactly the same environments at both sites. So it's very compatible with several versions of vCenter and several versions of Site Recovery Manager or the arrays. And we'll talk about that a little bit more later. So we're going to go over first we're going to go over some terminology. These are some words or concepts that we actually want to understand so that we can understand what we're configuring in Site Recovery Manager. A recovery time objective. This is the amount of time a business process is allowed to go down before the business actually says they need to be up. So if we were to say, for example, email has to be back within 5 minutes, for example, the business would be terribly upset or in danger of losing business if we couldn't get that service to be back in that recovery time objective. And then recovery point objective, what we're talking there is the maximum age of the files, meaning how much data was actually lost because of this disaster. For example, let's say that you have a web server that takes orders. A recovery point objective would be that if you have a disaster, you can only lose 5 minutes of that data. Those are orders that you can lose, and the business is okay with that. And obviously, most businesses will say, well, we want nothing to be lost, 0, but that's sometimes not possible because of how disasters happen. Okay. A consistency group in Site Recovery Manager is one or more LUNs, volumes, data stores that are replicated together at the same time. And inside that consistency group, all data is consistent. A data store group is one or more data stores that are treated as a unit inside Site Recovery Manager. So these two concepts are very much linked together because a common example of a data store group is a consistency group that is configured in the array and the SRM manages as a data store group. Protected site, that's the site that has the virtual machines that we want to protect. Recovery site is the site where we move the virtual machines to, where we have resources available for those machines to boot up and where we are going to be able to continue services. It is possible to do bidirectional. It is possible for a protected site to be the recovery site for another site. So we're going to talk a little bit about more, but it is very common to have protection in both sides. And there is something with the limits there that we have to be aware of. Failover would be the recovery of applications and services to the secondary data center most frequently when the primary data center faces a disaster. Failback would be to bring those VMs, applications, services to the original data center where they were protected in the first place. Reprotect would be that phenomenon that I had talked about, that when we have failed over, we start protection on the other direction. So Site Recovery Manager, when it's installed, it actually appears in the HTML5 UI inside the same vCenter interface. You'll basically just see a new logo down here when you go to your home that mentions Site Recovery. So there is no separate interface. There are some separate interface to configure some of the appliances, but the actual operation of Site Recovery Manager happen in the vCenter interface. So we have talked about types of recovery. I'm going to dive a little bit deeper here. A planned migration is also what you would call a site migration of VMs. This is an orderly execution where we are shutting down VMs in the source site, syncing storage, and bringing them up in the target site. For us to be able to call this a planned migration, both sites must be functional. And the different scenario, or most frequent scenario, is when there's a disaster. And disaster recovery is when we have determined that the original site is having problems, it cannot handle services, and we are going to have to use the recovery site to bring up those services. The difference here is that the original site does not have to be online, and if there are any errors, the disaster recovery workflow will actually ignore those errors and move on. So talking about use cases, the most common use case is disaster recovery. But there's other use cases that we can talk about. What's perhaps most important in this slide is that for all use cases, Site Recovery Manager allows you to test those use cases or those plans that you have. And you can actually do it in an isolated environment. So you can have an environment brought up that is not in the same networks, that is isolated from the actual production networks, where you can actually run some of your verifications, or application owners can run some of the verifications, and you can then clean up that environment and continue on. And this is one of the most important features of Site Recovery Manager. So one of the main reasons why people buy Site Recovery Manager for disaster recovery, it's the automation and orchestration when you have a disaster. If you were to do this manually and you were to try to get everybody on the bridge and try to figure out what VMs have to move first, you would lose a lot of time just making decisions. The fact that you can make plans, execute those plans, prepare those plans, and then just be able to, when disaster strikes, just be able to push a button and have those disaster recovery plans be executed, gives you the best RTO possible. When you have disaster avoidance, there's actually a lot of situations where you may not have a disaster already, but you may have a storm coming. You may have a situation where there's any number of situations that may threaten a data center. So disaster avoidance is the orderly movement. So basically using the site migration or planned site failover to be able to actually move workloads from one place to the other, or perhaps because you want to do load balancing across your data centers worldwide. The most important part there is that you're not losing any data when you're doing an orderly migration for disaster avoidance. And this is something that a lot of my customers use is a planned migration, meaning that they need to vacate a data center and they need to move to another hosting provider, or they built a new data center and they need to return an old building. So planned migration would be that situation. You don't have to move everything at the same time. You can basically say, okay, I'm going to do certain waves. And it's very common that most of the operational tasks with Site Recovery Manager are planning those waves and deciding what applications move first and what applications move later. So this is one of the Site Recovery Manager use cases that is actually used a lot by customers. I will mention that we do have solutions like HCX now that are dedicated for planned migration, and they probably are a better fit, especially if you don't want to be changing IP addresses. But I'll leave that to the reader. Just know that HCX is another solution that does planned migration as well. An interesting situation that you can also do is upgrade or patching or in general application testing. When you have the capability to bring up, do a recovery of virtual machines in an isolated environment, that allows you to be able to test patching, to test upgrades of the application, to test what would happen if scenarios without harming production and being able to do it in working hours. So that's also one of the big use cases for SRM. All right, I want to stop talking about use cases. We're going to focus now on a little of the deployment overview of SRM. And basically, there's three big things that you do in the beginning to be able to set up a Site Recovery Manager. First one is site pairing. Then we do inventory mapping. And then we have to worry about placeholder VMs and data source. So this is a screenshot. I want to say this is SRM 8.1, but it's very similar to 8.4. And what you can see here, if you can see my mouse, we have a vCenter in Boston and another vCenter in Vegas. They each have their platform service controller because these are on 6.5. And then we have a SRM server per location. And basically what happens is these two, the SRM server and the vCenter at a location are paired, and they are then configured to be paired with another duo, which is the vCenter and the SRM server in Las Vegas. In this case, we're also seeing VCIX replication here in the bottom. That does not have to be that way. You can use other replication methods, but it's one of the most commonly used. We're going to talk about why in a little bit, but also if you're testing in a home lab, this is something that is very easy to set up. So this is normally how you see things. It's a pair of duos is what you could call them. So talking about inventory mappings, this is where we decide, okay, what used to be in this place in the source site is going to be here in the target site. And there's several things that we have to decide. We have to decide the actual, whether it's a cluster, host, or a resource pool that we're going to basically be able to move the VMs from one site to the other. We're going to decide the folder locations, and we're going to decide also which network maps to what other network. We're going to dive deeper into that, but think about all the things that you need to basically decide in advance so that you can actually have a failover happen. So mappings basically provide default settings, and in SRM you can actually modify some of the settings later, but it gives a baseline. A good example was the network, but like I was saying before. Let's say that the network port group in the protected side was prod 100, and then the network port group is prod 200 at the recovery side. So by default, things that move from one side to the other, they will use that network when they come up. Something very interesting, if you haven't seen SRM before, it actually creates a placeholder VM in the recovery site. So you always know if the resources in your recovery site are being saved for that recovery event. They are very small. Of course, we are actually not completely putting those VMs there. That's the replication technology that will actually move the bits and bytes. But SRM uses what it calls a placeholder data store to store all of these placeholder VMs in the recovery site. So this placeholder data store has to be accessible by all hosts. It is also used in failback, so the source site must also have this one. There is one caveat there. If you're using storage policy-based protection groups, and we're going to talk about them in a little bit, data stores that this placeholder data store is not required. All right, protection groups. This is actually some of the building blocks of site recovery management. This is our way of grouping virtual machines together. In many ways, what people do with protection groups is they say, okay, these are all the VMs that are needed for a certain application. And you want to be careful here. You don't want to just move half of the application VMs and then find out that, for example, a web server needs to talk to a database. They're in different sites. They used to have sub-millisecond latency, but now they have 30 milliseconds of latency, and the application runs very badly. So you have to be very careful when picking out your application groups. This is probably some of the more operationally intensive tasks that you're going to do as an administrator. You're basically going to talk with your application owners, and sometimes they don't even know exactly what is entailed in their application. So this is one of those things that you want to test before you actually commit to doing some migrations. There is a bit, there's different ways, and here I mentioned that there's different ways that you can replicate the VMs. Very famous is Arraybased. There's also the capability starting with 8.3 of using virtual volumes, VCIX replication. There's all of these capabilities. One thing that you have to remember, you cannot have one virtual machine use more than one replication solution. Each virtual machine can only be using one. A good example, let's say that with array replication, which basically you have to put the VMs in the data store, and you want to choose that VM for replication with this replication, that is not allowed. It has to be completely just one-to-one mapping there. And another thing, a virtual machine can only belong to a single protection group. This is different from a recovery plan. You can have different recovery plans, but the protection group, the virtual machine has to be one-to-one ratio as well. Okay, I mentioned recovery plans. Recovery plans are basically your instructions, your automated runbook of how to do the recovery process. This is where you can also tell the site recovery manager, hey, I want to test this. I want to test this recovery plan, or I actually want to run this and cause a failover. Interestingly, here's where you can actually have more flexibility. When you create a recovery plan, you add protection groups, and you can add these protection groups in more than one recovery plan. So what you can do is you can have a recovery plan that is only one application. You can have another recovery plan that has several applications, and you can have a recovery plan that is a whole site. So this is where you can actually be very creative into how you do the actual recovery plan. Recovery plans, by default, they work with 5 priority groups. This is how you can tell inside a big migration, for example, that some VMs must come up first before others. So Site Recovery Manager will not allow VMs in the second priority group to come up before the first priority group has come up. Most likely, those VMs that are most important for your recovery time objective, that you want to have them in the first priority group. And then things like dev, test, etc., they can be in priority groups 4 and 5. But this is also important if you have application tiers. For example, you know that the database has to come up before the web server, before the remote desktop servers, for example. This is how you can determine that inside a recovery plan. Another thing you can actually set up in a recovery plan is dependencies. This is more granular even than the priority groups, because you can say that a particular VM should not come up before another VM, for example. The way that Site Recovery Manager knows that that VM is up is the same way that vCenter knows that that VM is up. It's basically using the VMware tool heartbeats. There are also shutdown and startup actions. And these are all these are all ways that you can customize your recovery plan. By default, the shutdown action will be executing a guest OS shutdown. And by default, it will wait 5 minutes for that VM to power off. If not, it will power off by itself. These are things that you just have to understand about the solution. But there are many things that you can actually do. You can actually tell it to do, you can actually tell it to run scripts, for example. Importantly, when you are doing a test, that only, let me go back here a little bit. I want to save it here. So shutdown actions are not used when you're doing a test. And that's important to know because the startup actions are run when you are running a test. The reason for that is when you're running a test, you don't shut down the source. So that's the only reason why. That's what you have to remember. Oh, when I'm running a test, I am not touching the actual machines that are running in production. But when you're doing a test, you definitely want to make sure that whatever you're testing is going to work later on. So that's why the recovery actions of shutdown and startup do run when you actually are doing the startup. I hope that was clear. And then we also have pre and post power on steps. These can be, these are things that normally we would do manually. For example, I'm moving a VM from the protected site to the recovery site. But let's say it's a VM that I have to modify DNS in the host records in Active Directory or some other DNS server manually. You can actually program these steps inside recovery manually. You can also run script inside a VM, and it can even give you a little notification inside the vCenter interface that the script ran correctly. All right, and this is probably one of the most used, especially if you don't have layer 2 extension between the protected and recovery site. IP customization, meaning that you can actually tell it, this VM when it was in the protected site had this IP settings, but when it comes up in the recovery site, I want it to have different IP settings. And you can even do, there's several modes for IP customization. You can even say, whatever was in this subnet, keep the last octet in the case of our /24, but make sure that only the subnet is changed, but you keep the last number octet of the IP address, for example. You can do that type of mapping so that when your VMs come up, you kind of know, okay, that VM that ends in 199 here used to be the 199 in the protected site. So there's multiple options there you can play with. So here we're looking at a recovery plan here, and I want to double sure that when you are having a recovery plan, you make sure that you understand that test and run are very, very different. Test, again, does not harm does not interact with the VMs that are running a protected site. Run will definitely start interacting with those VMs, whether it's disaster recovery or planned migration. It will actually cause changes in your production environment. So whenever you create a recovery plan, you definitely want to test it. And you can see here that once you actually run the test, you will have several steps, and your recovery plan is basically spelled out here. Some considerations with recovery plan tests. What SRM uses to be able to bring those machines on the recovery site are snapshots. So you can have tests that are very short-lived, or you can have tests that are very long-lived, but you have to have the storage to support those snapshots and those deltas that are building as you continue running these VMs. So you want to make sure that you don't cause an outage because of your test, right? But once you actually have a test recovery plan running, and you actually have your VMs standing up in the test isolated site, people can log in, whether it's to the vCenter console or because you gave them access to that isolated network. It's a very nifty tool. Now, when you finish your test, there is something called a cleanup, the concept of cleaning up your test. That means getting rid of those deltas, getting rid of those snapshots, and allowing Site Recovery Manager to return to the original state. You are not able to do you're not able to do another test, or you shouldn't be able to do you shouldn't be able to run those recovery plans if you haven't cleaned up. So please remember to clean up, just like with anything in snapshots. Remember to clean those up and make sure that you're ready for the actual thing. All right. We had mentioned this before. When we are running a recovery plan, SRM will try to shut down those VMs. And one of the things that the Site Recovery Manager does is it makes you confirm that you are really want to run this. There's a checkbox in the dialog that tells you, hey, what you're going to do actually has impact. So make sure you understand that. I think I made a good job of trying to explain that. One of the things you also have to know is SRM will always try to replicate the data after it has shut down the VMs to the recovery site. Now, this is very useful with plan migration. You want to make sure that you're not losing any data. But if you choose disaster recovery, it won't care if there's errors. If it cannot synchronize that storage from the source to the destination, it will continue. Whereas in plan migration, if it finds errors, if it finds it cannot sync, if it thinks it's going to lose data, it actually stops and tell you, hey, I'm running into this problem. And anything in your vSphere environment, in your vCenter, in your host that may be causing a problem can affect SRM. So you want to have your vCenter environment as clean as possible. But yeah, definitely there's a big difference between choosing plan migration and disaster recovery. One will care that data is completely consistent. The other one says, oh, I get it. There's no way to get the data. Let's go ahead and fail over. Yeah, and this is what I was mentioning. With disaster recovery, SRM will still attempt to sync storage, but will proceed after the errors. All right, so I mentioned this before, reprotect and failback. One of the things to understand there, and there was a big improvement with version 8.4, the reprotect action or workflow takes a little while. You basically have to start making sure that replication from the now primary site or protected site to the new recovery site is working properly. And we use our own technology. It is not change block tracking, but it's similar. Site Recovery Manager and vSphere, they use their own way to track those changes. With version 8.4, it actually by default tracks changes as soon as the VM comes up, and it allows this time to set up the reprotect to be much less than before. So that is one of the big reasons that you may want to consider upgrading to 8.4 is to have that enhanced failback time, which is much less than before. All right, there's another thing that you are going to be very interested when you're running tests or when you're running recovery plans is getting a report on how did that recovery plan go. So they're going to give you workflow names, execution times, which VMs took the longest, when the VMs will fail back, were you able to bring it up as the plan indicated. And these reports can be exported into anything that you can imagine, HTML, XML, CSV. And there are several reports. There's summary reports, there's detailed, there's VM reports. These are actually needed by some companies that have to prove that they have done their DR plans. So our Site Recovery Manager test plans serve as that proof. Sometimes they really want to see the failover event. All right, so I know that was quick, and I tried to make it as quick as possible, but that was mainly, this is the basic of Site Recovery Manager. Now we're going to be talking about more architectural things about Site Recovery Manager. So again, let's explain. You have a protected site and a recovery site. They always make a pair. With Site Recovery Manager 8.4, you don't have the option anymore to install it on Windows. It is now only available as an appliance, much like vCenter also moved to the VCSA. You support multiple versions of vCenter. There's a compatibility matrix, which is very good, and I highly recommend. I think I have the link somewhere, so that you can actually see which versions are needed. But one thing to know is that you want to have the version of SRM and vSphere Replication. If you're using vSphere Replication, they have to match. So if you have SRM 8.4, it has to be vSphere Replication 8.4. With 8.4, we actually had a new feature where they don't have to match at both sides. 8.4 can talk to 8.3. In the past, you had to be kind of at the same level. And there must be at least one vSphere host to provide the resources that SRM would need at each site. Okay, so this is perhaps the first diagram that we've seen. We're going to talk a little bit about the storage replications. So we've talked about vSphere Replication, which is a software solution. There's array-based replication, which you have to have the same type of array at both sides. You have to run a certain particular software and to be able to replicate and be able to talk to Site Recovery Manager. There's Vivo replications, where you also have arrays at both sides, and they have been configured in a manner similar to array-based, but just a little bit different. And we'll go into that. And you can also support things like stretch storage. And one that comes to mind is stretch vSAN configurations, where you basically are having two sites with low latency between each other inside the same vSAN data store, basically. So that is something that Site Recovery Manager also supports. So some high-level storage considerations. Array-based replication and stretch storage typically must be licensed. You are paying a premium for that. And the appropriate storage replication adapter has to be installed in the Site Recovery Manager server. This is typically this is managed by the array vendor, and we actually post which SRAs software is compatible with which versions of SRM. A little bit different in VVolts, there is no SRA. This is included with the VASA adapter for VVolts. And with vSphere Replication, the appliances have to be deployed and working before Site Recovery Manager can actually take advantage of them. One of the beauties of using stretch clusters or stretch storage, like I was talking about with vSAN, is that it allows us to do things that previously, especially with versions 5, you can only do with vSphere Metro Storage Cluster, which was zero downtime, meaning basically you're doing a vMotion. It's a cross vSAN to vMotion, basically. And you can do also planned maintenance. The biggest thing when you're talking about stretch storage, you have to understand that these VMs are not being shut down. In other solutions, in other scenarios, we are shutting down the VM and bringing it back up. But when you have stretch storage, the VM is not going down. So that means that layer 2 networking has to be the same. It has to be stretched between the two sites, because we can't change IP address. I mean, you could, but you probably have to do something like with a script. It's probably not the best thing. If you have stretch storage, you likely have stretch layer 2 connectivity as well. So again, we've talked about array-based, vSphere Replication, virtual volumes, and storage policy-based. Again, reminder, virtual machine cannot be protected by more than one replication type. Okay. All right, let's talk a little bit more about array-based replication. I mentioned the storage replication adapter. These are created and supported by the array vendor with guidelines from VMware. I'll tell you a good example that when we released version 8 and 8.1, we actually had to tell the vendors, hey, a lot of things have changed in our solution, so you will need to change the SRAs. From empirical experience and working with customers, I can tell you that 8.3 to 8.4, there was not a big change. So why this is important is because sometimes the array vendors can take quite a while to update their SRAs. In this case, when 8.3 to 8.4, no big changes, they released it kind of fast. But I had customers that when they were moving from 6.5 to 8.x, they were waiting 6 months for the SRA to be available. And that depends on the array vendor. So here we have another diagram. This is just array-based replication. You can see the SRA basically is talking to SRM. SRM is only talking to the array and asking, hey, is this replicated? Is this consistency group? Is this data store group? Is it ready to be failed over? And when the array talks back to SRM and says, yes, I've done my replications, data is consistent, then SRM can take actions there. So there's actually no, the actual movement of data happens between the array network cards. It doesn't happen at the vCenter level, the host level, etc. But SRM needs to know what's going on.
So, sorry to
Yes.
interrupt you, Ariel. There's other tasks that the SRA takes charge of. A good example would be if you want to have a application consistency, the specific SRA, let's say Dell EMC's SRA for I don't know, BNX, will take the required steps to have that application consistency from a LUN perspective or volume perspective. So things like volume snapshots, right? Those are going to be coordinated and executed by the SRA. So as Ariel said, the SRA is in charge of basically talking back to SRM and letting SRM know that the replication is ready, right? But there are other tasks that can be executed in case that they are required. Sorry to interrupt you.
No, that's great. This is why we're here. And if anybody has any questions, I saw the chat there and somewhere I answered already, but more than happy to discuss anything in this sessions. We're all trying to learn together. So especially when you hear something that perhaps is not very clear in the documentation and you can get that little tip, sometimes it can help a lot of things. So more than happy to have Agustin and Phoebe give me any tips here. All right, I'll continue here. We're going to talk about vSphere Replication. This is a separate appliance that you download from VMware. There's a vSphere Replication server and vSphere Replication actual appliances that do the replication. The big difference here is that it doesn't have to rely on the VMs being in a data store to be able to, basically do the synchronization of data from one side to the other. And that can be really helpful because you don't have to do a lot of storage remotions. Let's say in the particular scenario where you're moving VMs in waves from one data center to the other, if you're using array-based replication, that literally has to be a LUN that is replicated from one side to the other, meaning that the VMs have to be on that LUN. With vSphere Replication, you don't have that situation. And they actually have some tables that Cato Grace built comparing the two. And we'll talk about it in a little bit. Yeah, those are the ones. So he has a very good array-based replication versus vSphere Replication blog post. Cato Grace has been the technical marketing, technical marketing person for Site Recovery Manager for quite a while. And I think right now he's even doing the backup PM. So he's been involved with SRM. Great resource, as well as the VMware SRM Twitter account. He also lists out this vSphere replication fact that goes into frequently asked questions, that goes into a lot of other scenarios or conditions for vSphere replication. But I wanted to highlight some of these that he put out in that blog post, because they can make you they will make you choose different things when you're designing a solution. So one thing that's important to understand is write order fidelity. When you're doing arrays-based replication, and that will be the left column, you can actually support and you can actually say, we have write order fidelity in this consistency group. Well, whereas vSphere Replication will only guarantee that within the VM disks inside a particular VM, but it cannot guarantee that across multiple VMs. So what Agustin was mentioning before, where you can have consistency that is supported by the array, that's what we're talking about. We're talking about that as an application, a whole application, several servers, you can be assured that they are consistent between each other. Whereas with vSphere Replication, you can only assure consistency individually. And maybe, you can have discrepancies when you bring up the recovery plan, because, that's the solution cannot do that. You can see here when we're talking about replication level, when we're talking array-based replication, we are talking at either the LUN, which is normally VMFS, or NFS data store level, replication level with these replications at the VM level. Where is this replication configured? For array replication, it's on the array. With vSphere replication, you are doing it in the vCenter, in the web client. What storage is supported? Well, the vendors have to actually come out and tell you that a particular solution supports SRM and has an SRA. Whereas vSphere replication, anything that's on the vSphere HCL is supported for vSphere replication. Some other interesting features or caveats. If you want to use vSphere replication, you can only replicate powered on VMs. Meaning templates, link clones, ISOs, any non-VM files will not be replicated. But if you're using array replication, you actually will you replicate anything in that LUN. If you are using RDMs, physical and virtual are supported with array replication. Only virtual is supported with vSphere replication. And if you have Microsoft clusters, sorry, you cannot replicate those VMs with vSphere replication, just because vSphere replication cannot replicate disks in multi-writing mode. So that run disk is a problem. All right. So now we've talked about the two biggest and the two classic array replication types. You know, vSphere replication has been here for 5 or 10 years, give or take. We're going to talk about a third option, which is VVolts. And VVolts only started being supported in version 8.3. And you again are configuring things in the array. You're configuring something called a replication group. That replication group is actually guaranteed to be consistent. So you're gaining some features of each. You're able to do replication groups where they can be as small as a single VM, or you can include several VMs in a replication group. But that replication group is consistent. You know, when the array replicates it, they are actually guaranteeing consistency there. So you can actually pick up VMs and guarantee consistency, which is kind of like a middle point between array-based replication and vSphere replication. And again, one other thing is we don't need an SRA software for VVolts replication. That is included in the VASA provider.
I have a comment there. Sorry to interrupt you. When you hear VASA provider, most of the times that's a software component that is provided by the storage vendor. So VASA will be an appliance that will basically help you manage the all the functionalities on the array side from a VVolt perspective. So that's why we don't need an SRA in this case.
Yeah, they move it around basically, but it's kind of the same thing. Okay, so this is just a different situation here. You can have, even if you have several sites, you can have replication groups that go from one site into the other. And we're going to talk about multi-site configurations in a little bit. But in general, VVolts and those replication groups are a bit more flexible than what you can do with array-based replication. All right, so we were talking about this before. Some more specifics on those array-based protection groups. Again, where the virtual machines are located, this really matters. I have to, sorry about that. Put it in mute. So very important here is all the virtual machines on the data store have to be protected by Site Recovery Manager, and they all have to be in the same protection group. And this, I should have put this in red. It is not supported, advisable, or recommended to only protect a subset of the virtual machines in the data stores. This is known to cause problems. So you can see here 3 different setups, actually 2 different setups. Here you have 3 logs being replicated as part of a consistency group, and another consistency group can be just 1 log. So I'm hoping that some of these tips stick with people, right? VVolts protection groups, there are some caveats there. You have to ensure that you're in VVolts version 2.0. That's where the console of replication groups is there. So ensure that your array supported that. Again, everything SRM You should be checking the compatibility matrices. And you basically add them to that protection group by associating them with a storage policy that is configured for their replication. So you don't actually need to move them to a data store or things like that. You basically just give them a storage policy. So here, just talking about, again, the concept that we had introduced before, vSphere replication protection groups, you add the VMs on an individual basis. They are not tied to any storage type. The only caveat there is if you have both array-based replication and vSphere replication, make sure that the VMs that you have on vSphere replication are not in a LUN that is currently being replicated by the array. All right, so this is probably one of the most fun ones that I've seen. I haven't seen many examples of this in a while, but storage policy-based protection groups are, very similar to what we saw with VVolts. You have a storage policy that is associated with the basically the storage of the VM, and you can actually have that be for the storage policy to have replication in its settings, and apparently it's used a lot with tags, and especially when creating VMs with realized automation, so that VMs that are created are automatically protected. I don't know if any of you two have any experience with that, but if you do, this would be a great moment to talk about it, because I didn't find a lot of information there, and I haven't seen it in a while, so it would be interesting to see it in the lab. All right, I want to talk now about some of the dependencies that Site Recovery Manager has. Again, Site Recovery Manager depends on vCenter and the vSphere infrastructure. vSphere infrastructure depends on things like NTP, DNS, network routing, firewalling. Active Directory may be part of how your vSphere infrastructure is set up for permissions. So these things have to be in place at both the protected and the recovery side. You obviously, if you want to be able to do a good disaster recovery or a good plan migration, you have to make sure that your base vSphere environments are stable at both sides. All right, so now we're going to talk about some of those, where do we have some flexibility with SRM configurations. So some components have to be identical, but others, because we have different data centers, because data centers can be in different versions, you can have just a little bit of difference. So I mentioned this before, 8.4 is able to work with 8.3. You will have to have version 8.x at both sides. You can't replicate 8 with 6.5, for example, which was the previous version. But other than that, vCenter Platform Services Controller, as long as they're listed on the intercompatibility matrix, you should be fine. vSphere replication has to be at least 8.x. Again, between each site, SRM and vSphere replication must be at the same version. You can have, especially if you're running 6.5, for example, you can have a Windows SRM or Windows VCSA, vCenter. That's not a problem. As long as the arrays, as the versions of the arrays are compatible, you can have different versions of the arrays. And the databases, it used to be that you would have different databases, but most of it now is PostgreSQL. It doesn't matter. So you can have some variances between installations, just not a lot. And remember to double check all of them. So some sizing guidelines. There's currently 2 models to deploy SRM. There's a light model, 2 CPU, 8 gigs of RAM, and there's a standard, which is 4 vCPU, 12 gigs of RAM. What's your determination there? Are you protecting less or more than 1,000 virtual machines? Importantly, with licensing, we have some considerations, but I think the most important part is that you have to have licensing in the protected site. If you want to protect 100 VMs, you have to have a Site Recovery Manager licensing that will protect those 100 VMs in the source site. However, if you want to do bidirectional protection, then you must also license your recovery site. All right, now we're going to talk about some site recovery manager topologies: active, passive, active, active, bidirectional, multi-site, share recovery, and share protection. And most of these are very simple to understand. You can do things that are different from what I'm going to show, as long as you take into account these two rules. Each virtual machine can only be protected by one site recovery manager pair. Okay, you cannot have that machine be in different site recovery manager pairs. And you cannot fail over that same virtual machine to different locations. So you can only define one location for a virtual machine to be recovered to. They seem like simple enough, but with some of the topologies, you understand that why they have to explain this out. So active passive is probably the most expensive because you have an active site and a recovery site. The recovery site is doing absolutely nothing but waiting for an event. So the resources are there, but the hosts are basically running almost nothing. Active is when you actually have workloads running in your recovery site. And a model that a lot of people use is they will put dev or test machines in the recovery site. So they are actually, those hosts are being used in some way or manner. But if you were to need that capacity, then you can turn off the dev and test and fail over the protected site. Of course, managing this is a little more intensive, more resource intensive, more operational intensive, but you are taking more advantage of the hardware that you have bought. When you have bidirectional, then you actually are saying that, at any point in time, you may have one of the two sites fail, and you will be able to have enough resources in the other site to run workloads. So this will be a different scenario because you have production in one side, production in the other side, but you're running half and half, and you're basically load balancing between the two and giving yourself some slack room between, if I have a failure on the East Coast or the West Coast of the United States, I can move all my workloads to the other place. Again, this means that you are licensing both sides, and we're going to talk a little bit more about the maximums when you have this kind of configuration. Multi-site share recovery, you have several sites that all share the same VR location. I've seen customers do several production sites across the world, and they have a dedicated VR data center where any of those can go ahead and put their recovery plans to work. I would say that the line here goes from the remote offices to the main data center. A bit different from the next one that we're going to talk about, which is multi-site share protection. A single site fails in this scenario, but it's able to, basically assign some machines to one data center, some machines to other data center, and maybe a third or a fourth, as long as there's SRM site pairs, server pairs. So the arrow actually goes from this main data center to the other data centers. And here's what I call the chain protection, a multi-site chain protection, where if site A were to fail, it can fail its VMs over to site B, and site B's VMs are actually protected in site C, and site C are protected in site A. So you have a situation here where you have basically a chain of site recovery management. Sorry. Okay, so we're going to talk now about protection maximums, and this is probably one of the things that we're going to run into when we're designing SRM solutions. The total number of virtual machines configured for protection across all your replication possibilities are 5,000. That's across everything. If you have, we're going to go into some examples. If you're using Arraybased replication, you can actually reach that 5,000. But if you're using vSphere replication, you can only do 3,000. And this is an upgrade. Prior to 8.4, the number for vSphere replication was 2,000. For VVolts replication, you can only do 500 machines. These may change with time. With time, as the software gets better, as we have more resources, we typically bring them up. But it's important to know this. I'm going to continue here. Total number of virtual machines configured for storage policies protection, 2,000. If you have stretched storage, it's 1,000. So you can see how depending on what what replication technology you use, that's going to change the number of machines that you can actually say are protected with one SRM site pair. Of course, you could always create another SRM site pair, create another vCenter, move things around. When you have large environments, you have to do some of those things, but it's important to understand what the limits for a single installation are. Virtual machines per protection group, 500. Total number of array-based protection groups and vSphere protection groups combined, 500. Total number of recovery plans, 250. Total number of protection groups per recovery plan, 250. So a lot of these things will come into play when we're actually doing design work. So just again, trying to make it very clear, total number of protection groups can exceed or 500 combined, right? So let's look at this example. Protection limit for Arraybased replication is 5,000 VMs. Protection limit for V's replication is 3,000 VMs. If you are using both, the limit is still 5,000 VMs. You don't add 5,000 from array, 3,000 for vSphere replication, making 1,000. That's not how it works. So you're very constrained. It's still to the limits. The limits are the limits. So important to know. Okay, so I had mentioned this before. When we have bidirectional protection, the limits apply across both sides, not per side. So if you are protecting 3,000 VMs from one side, from site A to site B, you can only protect 2,000 VMs from site B to site A because 5,000 is the global limit across both sides. So you have to be very careful there. If you're thinking of using bidirectional protection, are you even able to do the reprotect in the same amount of VMs that you were thinking before? All right. Total number of concurrently running recovery plans, 10. And how many VMs can be in those recovery plans? 2,000. So that means that if you have 5,000 VMs, the maximum being protected, at any point in time, you can only be running a recovery plan that has 2,000 VMs. That is a limitation. Once that plan has finished, you can run another one for 2,000 and then another one for 1,000. So you want to be very careful of putting your most important VMs in that first recovery plan, and putting dev and test maybe in other places. And you still have all of those tools that we have in the recovery plan, the priority groups and all those things. But it's very important to understand these limits that you have when you're designing the operational part of your recovery plan. All right, so other limits, you can only configure one IP address per VM for IP customization. Some people do set up several IP addresses, but if you want SRM to be able to change those IP addresses, it can only be one. And in a shared recovery site configuration, where you have several SRM instances hitting one DR location, the maximum of SRM installations is 10 per vCenter. All right, so now we're going to get to something that is always a fun topic: network ports. I'm not going to be explaining each one of these, but I wanted to include them. What I want to feature here is that we have requirements for vCenter server, platform services controller, if you still have it. Your web client needs to be able to talk to things. Your site recovery manager servers need to talk to things. Replication appliances, replication servers, and even the ESXi host need to talk across the environment to be able to pull all of these together, all of these functions. So this is just a dump from the, basically a copy paste from the documentation site. That you can see here, site recovery manager needs to talk to vCenter, to the PSC. Site recovery manager needs to talk to the recovery site ESXi hosts. They need to be able to talk. Site recovery managers need to be able to talk to each other. And then your vSphere web client, wherever you are running your access into vCenter, it needs to be able to reach the site recovery manager directly for some things. And you have comments here about why it has to be able to access those things. One thing I'll mention here in the site pairing, if especially this is a situation that I'm running with a customer, if you have enhanced link mode and you have several, let's say you have 8 vCenters in enhanced link mode, and you maybe only want to do site recovery manager in 2 of those data centers or vCenters. Well, because of the way that the dialog is displayed in SRM, you want to have the firewall rules open to all those vCenters. If the dialog for SRM for the configuration of the site pairs cannot talk to them, it will actually error out and you cannot continue. That's one thing that we're dealing with in 8.3, and we're hoping to have that set up differently. But it's always a good idea if you have enhanced link mode set up to include all those servers in these firewall rules, even if you don't think you're going to use SRM as of yet. And here's some more ports for VC replication. Hosts need to be able to talk to the appliances, and site recovery manager needs to talk to the VC replication appliances on recovery and protected sites. All right, this is the last section. I know that you have been hanging out for almost an hour there. Really appreciate it. This is a very short part, but it contains some of the really important links that you're going to use to figure out if you are running a supported configuration. So this link over here brings up the compatibility matrix, and it actually guides you how to check, how will this site recovery manager, whatever version it is, work with another VMware solution. This is how you would do it, right? We also have the site recovery manager storage partner compatibility guide. This is where you can check the SRAs, and the VVolts, that's a provider's compatibility guides. One thing I wanted to show here is this is what it looks like when you're looking for an SRA. You definitely want to make sure that you have the right SRM version, the right partner name, the array manufacturer, and then you will find what protocols are supported, what features are supported. You can see here, for example, stretch storage, and what exact software you need to be installing. Yep, and you can see VVolts only supported in 8.3 and 8.4, and so far it's only four vendors that are so far compatible with VVolts. All right, so this very short, I tried to make it as short as possible, but this is meant to give you a good base for site recovery manager, so that when we're talking things about in the design session that we're going to do, you have some of those concepts, the protection groups, and you understand some of those limits that we have to architect around. We've only talked really about limits at the software level, but then we also have to talk when we actually do design, constraints, requirements from the customer side and from their needs. So I hope that you enjoyed this, and I'll give it back to Agustin.
Thank you so much, Ariel. This session was great. It's a very, very good technical introduction to what SRM is capable of, and how we get it up and running, right? And basically cover the most important aspects or terminology that will be key during the design session. So I would like to open the mic or the Q&A section for anyone that is part of this webinar session. So if anyone has a question, this is the time to do it. Feel free to ask whatever you have on top of your mind. So, by the way, I have some questions in the meantime. So the first one, you talked about the placeholders, right? The placeholder VM. The placeholder VM is created on the basically recovery side, right? So I have a question regarding that. The placeholder VM is powered on. It's going to be consuming resources from that site.
I don't think so. No, it's not meant to be powered on. This is just something that we can see that there's an SRM protection going on there.
Okay.
Yeah.
So it's not. Go ahead. Sorry.
No. I was going to say you probably have way more experience than I have with SRM. But but in general, what you're doing with the placeholder VMs is basically saying this VM is registered to a host, so that when the recovery plan has to execute, it will actually say, okay, I see the VM. I'm going to do the changes that I need to do with the inventory mappings that we have displaced, and it can actually start. Of course, it always relies on, the actual data for that VM has to be replicated with some of the storage solutions. But it actually, one of the other things that we haven't talked about is when you export and import configurations in SRM, one of the requisites for that import to be successful is that it actually has the inventory. So being able to have those placeholder VMs actually gives you a lot of the visibility that SRM needs from vCenter to be able to do functions.
Got it. Okay, so that's important to keep it on top of your mind, because it's you will not need to design the target environment from a resource perspective to have those VMs running, right? So obviously, if you're gonna have like a warm site, you will design based on the active workloads that will be running at any time on the recovery side, and the other workloads that might be failing over to that side, right? So I have another question, and this is we got a very good comment from one of the attendees that is happens to be one of the most expert guys in networking, NSX, whatever. If you think about software-defined networking, not just from a VMware perspective, but also from a industry perspective, this is the guy. So we have Waldemar Pera here. He's a colleague and also a very good friend of us, and he mentioned something very important. We can use HCX with SRM, right? So think about a DR to the cloud, right? HCX can play a huge role on that specific scenario. It will help us to do the replication, obviously, but also help us to reduce the amount of bandwidth consumed, right? Because there are several different network optimizations with HCX. So that's something that we didn't cover on this specific session, but I think we will have a little bit of information on the next session. So Walde, do you have anything to mention here? We're gonna open the mic so you can provide some of your knowledge. So go ahead.
No, thank you. No, the idea here is additional the option with the replication based in BFI replicator or BRI, VVolts, is possible the use HCX. In this case, is the additional the use case mentioned Ariel for recovery or protection side is improving the replication side, and HCX has improved several steps embedded, for example, for optimization the disk replicator. So especially when the customer is use this replicator capability for site recovery manager and try go to some hyperscale site DMC or another possibility, is possible use combine these capabilities embedded in the HCX with the site recovery manager. Is another option, is a new one, especially again when you move it, maybe not traditional premise on premise, or maybe traditional more and consumer, for example, BMC. That is maybe, for example, the first idea to start to thinking about this additional option for the integrated is SRM.
Exactly. Yeah, I can remember when HCX came out to the public. One of the key use cases, or the most important use case was migrations over to BMC or DR as a service to VMware powered clouds, such as IBM's cloud and Oracle cloud and so on and so forth. So as Waldemar just said, HCX helps in those scenarios to reduce the amount of bandwidth, because HCX is a totally different product, right? it's a product that will require its own session, technical session and design session, obviously. But from a high-level perspective, it helps you, for this specific use case, to optimize the replication between, like an on-premise site and maybe VMC on AWS. So it's a very good option.
Very cool. We'll make sure to include that link that was shared and shown in the slides as well.
So I have another question, comment, or thought. So you talked about cross vCenter vMotion. Is that something that could happen at, on any architecture, or what do we need from an underlying infrastructure perspective to make it happen?
That's a good question. I honestly, I didn't come prepared to answer that one. What I saw a lot, and it was mentioned a lot where you had shared storage. So you're basically saying that VM is not going down when you're doing the vMotion. So if you have layer 2 connectivity, whether it's provided by NSX or Cisco OTV or other solutions, and you have shared storage, it's probably those are probably the requirements, but I can't tell you for sure.
Yeah. So when you say shared storage, for everyone watching this session, is basically like Metro cluster, right? Every single storage vendor out there has its own kind of a distributed shared storage across sites. Obviously, there's tons of different considerations from a physical perspective to make it happen, right? If you wanna have that kind of approach or that kind of architecture, it will be super expensive, right? But it depends on the business requirements. If the business can justify having near zero downtime, or maybe zero downtime, since we are doing vMotion across data centers, well, that's a feasible option.
Yeah, and it also requires certain latency requirements. We have different capabilities with vSphere 7 for cross vCenter vMotion than with vSphere 6. So yeah, that's an interesting. I don't know if we'll be able to put it in our design session, but that's an interesting thing to explore, especially if you have the infrastructure that may meet those requirements.
Exactly.
Is that the one that used to be a Fling before vSphere 7?
Cross vCenter vMotion, yeah, Fling. That's right.
Well,
okay.
cross vCenter vMotion was present. I think it was since vSphere 5, if I'm not mistaken. But on 5.5 and onwards, it was already supported. And then you got the different TCP IP stack for ESXi, so you can do clever stuff, but that's a totally different story.
Yeah, we actually included into the product with 7 update 1C. So we'll include it in the PowerPoint.
So Ariel, thank you so much for your time. Thank you for sharing knowledge with us. And thank you everyone for joining this first session of the Tech Webcasts. We're gonna be publishing this session on YouTube. It will take like 1 day since we need to edit this recording, but it will be available for if you want to see it before you join the design session as a reference, it will be there. And if you want to share it with other colleagues or friends, please feel free to do it. So thank you so much. Thank you, Phoebe. Thank you, Walde. Thank you, everyone else for putting time into this. And we hope you enjoyed and maybe learned some new stuff here. So thank you so much. Thank you. Goodbye.